Hello all. This video is a continuation of Introduction to Embedded System Design and MSP430 architecture. So the peripherals with the byte access in MSP430 microcontroller would be port 1. So in the port 1, we will be having the selection pin, the register enable, interrupt enable, interrupt edge select, interrupt flag, direction, direction pin, input pin, and also the output pin. So the special functions in this microcontroller would be SFR interrupt flag 1 and 2, SFR interrupt enable 1 and 2. So interrupt enable we say it as IE, interrupt flag we say it as IFG. So input pin as P1 input, output pin as P1 output. Direction pin we mention as DIR, interrupt flag as mentioned already IFG, interrupt edge select is IES, interrupt enable is IE, selection pin is mentioned as ESEL, register enable is mentioned as REN, selection is mentioned as SEL. So we are going to see the MSP430 CPU. Memory data bus will be there and address bus will be there. Program counters, stack pointers, status of the signals will be mentioned in the status register. Constant generator, general purpose registers to store the program. Arithmetic logic unit to do the arithmetic operations and the logical operations will be present in the microcontroller. So here we will be having the zero flag, carry flag, negative to mention the negative, negation, to mention the overflow flag, registers to store the programs will be there in the CPU. So address bus to transfer the address bits, data bus to transfer the data will be present in the microcontroller of MSP430. So here the program counter is mentioned as PC, which is R0, stack pointer SP, which is mentioned as R1 register, status register SR, constant generator CG, general purpose registers. Rest are the general purpose registers. So the 16 registers are there. The generous set of 16 registers is a characteristics of RISC CPU. So these registers are usually for storing the programs and the instructions. Register to register operations takes only during the clock cycle. 4 special purpose registers are there. One is a program counter. Next one is a stack pointer, status register, and next one is a constant generator. 12 general purpose registers are there. So the program counter, this contains the address of the next instruction to be executed. So it counts or calculates the next instruction which is to be done. This will be aligning to even the address so that the low significant bit of the PC is hardwired to 0. Next one is a stack pointer. The stack pointer is used by the CPU to store the written address of subroutine calls and interrupts. The stack pointer is usually initialized into the random access memory by the user and is aligned to even the address. The stack pointer usually holds the address of the most recently added word in the stack and is automatically adjusted as the stack goes up and down. So this stack pointer will be initializing the random access memory. This will be done by the user only and it will increase after one instruction. So status register, this contains a set of flags whose functions falls into 3 categories. The most commonly used flag is nothing but the carry flag, zero flag, negation flag, and the V flag, which gives information about the result of the last arithmetic operation or the logical operation. Decisions that affect the flow of the control in the program can be made by testing these bits. Setting the GIE bit enables maskable interrupts. The final group of bits is the CPU off, oscillator off, SCG0 and SCG1, which controls the mode of operation of the MCU. So here we have the description of the pins. V is nothing but the overflow bit, overflow flag. SCG is the system clock generator 1, system clock generator 0, oscillator off, CPU off, GIE, general interrupt enable. So negative bit N or the negative flag, or the 0 bit 0 flag, carry bit or the carry flag. So we have CPU registers also, constant generator registers. 6 commonly used constants are generated with the constant generator registers. Mainly R2 and R3 will be performing this work. Without requiring an additional 16-bit word of program code, the constants are selected with the source register address modes. So the constant generator advantages are like no special instructions are needed for the microcontroller, which is to be given by the user. No additional code word for the 6 constants are needed. No code memory is separately needed to access the memory. I hope you would have enjoyed the video, enjoyed learning. See you in the next video. Until then, it's bye from Radhika.